Howdy, y'all. It is so lovely to see your shining faces. Welcome to the next installment of Unit 10, working with non-right triangles. So last week we talked about the law of sines and when to use the law of sines. We talked about the ambiguous case, which in my opinion, that was an email, which in my opinion is the hardest part of this unit. And today we are going to talk a little bit about the law of cosines. So the law of cosines is when you have a fancy dancy non-right triangle right there, and we're going to use the same naming conventions that we use with law of sines. So our angles are represented by capital letters, and then opposite of big A is little a, opposite of big B is little b, and opposite of big C is little c. So my side lengths are all lowercase letters. So here we are, the law of cosines. And the formula that we are going to use, or not that we're going to use, the formula for the law of cosines is as following. I'm actually going to make this a little bit smaller so I can write right next to it. So check this out. A squared equals B squared plus C squared. Looks very familiar, yes? Much like our old friend, the Pythagorean theorem, yes? I'm not done yet. Here we go. A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A. My friends, that is the law of cosines. Or I should say that's one form of the law of cosines. This has the side A isolated. So if like, oh, we're trying to solve for side A, look, it's already isolated. What if I wanted to have side B isolated? So B squared equals, it's going to be A squared plus C squared minus, let's follow the pattern, 2 times these two, right? So 2 times A times C times the cosine of the opposite angle of our unknown, so the cosine of B. And then finally, the last iteration is C squared equals A squared plus B squared minus 2, following the pattern, times A times B times the cosine of C. Booyah. Okay, so y'all, I think my understanding, if I'm understanding my colleagues correctly, I think we're going to give you these formulas, or at least one iteration of these formulas, probably that top one for the test, so you don't have to memorize those. But these are the ones that we are going to be using. So when we talked about the law of sines, I gave you a very specific, the specific situations when to use law of sines. And we have the same type of things for law of cosines. When do we use law of cosines? So if you are given all 3 sides of a triangle, so if you know all 3 sides, that's when you're going to go to law of cosines, right? Because I can't use law of sines there, because for law of sines, I need to have at least one angle. So if I don't have any angles, I'm going to use the law of cosines, right? The other time I'm going to use a law of cosines is for when we have 2 sides and the included angle, the angle between them, the angle that they're kind of hugging together. We call that SAS. So if you have 2 sides and the angle between them, you would use a law of cosines. Now, y'all, if you can't remember when to use law of sines, law of cosines, it will become very obvious when you start doing the math. If you start like trying to get set up in the law of sines and you're like, I can't use the law of sines because I don't know this thing. Guess what? Just use the law of cosines. Same thing here. If you start plugging stuff in, law of cosines, you're like, I don't have enough information to use this, then maybe you should go use law of sines. So if you can't remember specifically which situation to use, just plug something in, start trying. And if you got the wrong one, skip over to the other one. But if you choose to remember, these are the situations where law of cosines are the most handy. All right, so let's do a couple of examples. We're just going to dive right in. I want you to solve the triangle. And remember, when I say solve the triangle, y'all, that just means to find all of the missing sides and angles. And I'm actually going to draw so many emails. I'm going to draw it for you. Boop. Let's do that. Let me scoot it over a little bit. Okay, so I'm going to make this angle B right here, CA. I'm going to make this side A 21. Angle A is going to be 40 degrees. and this is going to be 32 degrees. Okay, so let's see. I have, looking at this, I have a, hang on, let me make, I have two sides and the included angle between them, right? So this is not an ASS situation, which is the ambiguous case for the law of sines, because ASS would mean that the angle that I'm using, angle side, the angle wouldn't be between the two sides. But here, since the angle is between the two sides, it's not the side angle or angle side situation. So this is not the ambiguous case for law of sines. This is going to be law of cosines, right? So that's the difference there between these guys. So the first thing I'm going to do is I'm going to write down the stuff that we know. So I know side B is 21. I know side little c is 32. And I know the measure of angle A is 40 degrees. Y'all, on my last videos, I haven't been putting in that little m there, which means the measure of, which is technically correct when I'm talking about degrees. So my apologies for that. I will start doing that going forward. Okay, so now looking at this, I'm trying to think to myself, what do you want to start with? I think the easiest thing to start with here would be finding the measure of that missing side. So let's go ahead and find that missing side, and that side is A. So looking back up here, let's just use that guy right there because I already have the A isolated out front. So I'm going to go ahead and rewrite this formula. So A squared equals B squared plus C squared minus 2BC times the cosine of A. Okay, now y'all, all you have to do is, no, wait, I'm trying to be artsy for a second. Here we go, there it is. Oop. Oop. Get it? Do you know what it is? All you gotta do is plug it in, plug it in, plug it in. So you have all of these numbers, y'all just pop them into where they belong in the formula. That's all you gotta do. So let's do that. So A squared equals B squared. So B is 21. C squared, C is 32. Minus 2 times B is 21 again. C is 32 again, times the cosine of 40 degrees. So I'm just gonna plug in the numbers. Now, please be careful here, because in the past when I have taught this, this is the part where students get a little flummoxed. For some reason, they get confused, like typing this into their calculator, or they put a plus sign instead of a minus sign. So just be careful, because this is, like I said, where I get the most hiccups with students working with the law of cosines. So you are definitely going to need a calculator for this. You can just type it straight into the calculator if you want to, like just type that whole thing straight into the calculator, especially if you have a fancy graphing calculator, you can do that. I'm going to go ahead and write out a little bit more just so you can kind of see my process. Please make sure that your calculator is in degrees. I actually was doing this earlier, getting this ready to do some notes, and spent kind of a long time trying to figure out what I was doing wrong when I discovered my calculator was in radians, and that it messes up your final answer. So here we go. So I'm going to do 21 squared is 441. 32 squared is 1024. 2 times 21 times 32 is 1,344, and I'm going to add on that times cosine of 40 degrees at the end, and then triple check that I'm in degrees, which I am. So now I'm going to put all of this in my calculator. So I'm going to say 441 plus 1024 minus, I'm going to put this in parentheses, 1344 times the cosine of 40 equals, and I get 435.436. And the final step, I'm going to take the square root to get that squared off of there. So A equals, so second square root, and I'm just going to say answer. And here I'm not going to round it and type in my rounded value. I'm going to let the calculator do that for me. So I get that A is equal to 20.87. Now, sadly, they didn't give me units on the original triangle, units of length. So I'm just going to, I don't have to include units. I'm just going to leave it like that. Now, y'all, a couple of things I want to mention. First of all, for the sake of rounding, The hundredths place is usually pretty okay, especially if you're not rounding in the middle of the problem, if you're letting your calculator do all the rounding for you. So I'm cool with the hundredths place. The other thing I want to say, I know a lot of you, when you take square roots, very rightly so, are making sure to put a positive or negative in front of the square root. You definitely should. But for this, since I know that I'm working for a length of a side, I know that it has to be the positive answer. I'm not going to have a negative length. So for this, you do not have to put plus or minus when you are taking the square root, because I know since it's a side length, I know it's going to be positive. Okay, so getting back, I'm going to have to delete this super fancy artwork down here. So getting back to this, so now y'all, I have an angle and its opposite side, which means I think I'm going to shift over to law of sines, because I don't have to do quite as much plugging in for the law of sines, which means, in my opinion, I have less opportunity to mess up. And you can totally do that. You can like start with law of cosines and then jump over to law of sines, or you can start with law of sines and then hop over to law of cosines if you want. It's all going to work. I just kind of like the law of sines better, especially if I know that I'm not in the ambiguous case. So here we go. I have the angle A and side A. So I'm going to say, okay, so the sine of A over A is equal to the sine, let's go for B, sine of B over little b. So let's plug those in. So the sine of 40 degrees over 20.87 equals the sine of, I don't know what angle B is, over 21. I'm going to do some cross multiplication. If you have no idea how to do that, if you've forgotten, go back and watch my other video on law of sines, the intro to law of sines. I talk a lot about that there. So I know I'm going to have 21 times the sine of 40 degrees divided by 20.87. That is going to be equal to the sine of B. So I'm going to do that. 21 times the sine of 40 equals, divided by 20.87. So notice I'm not writing anything down. I let my calculator do the rounding. So I have 0.647 equals the sine of B. And then to figure out what the angle B is, I have to undo the sine. So that means I'm going to do the inverse sine of 0.647 equals B. So I'm going to hit second sine, second answer, so I'm not rounding, equals, and that tells me that 40.30 degrees is equal to B. Holla! Okay, so let me get up here. So this is going to be 40.30 degrees. All right, y'all, I know all three sides and I know two angles. So how, pray tell, might I figure out that angle right there? I can't hear you. So if you were saying, Ms. Ray, we totally just like subtract those angles from 180 degrees because all the angles in a triangle add up to 180 degrees. Congratulations, you were exactly correct. So I'm going to do that real quick. I'm going to say for angle C, 180 minus 40 minus 40.30 equals 180 minus 40 minus 40.30 equals 99.70. So 99.70. And just like in the law of sines, y'all, whenever you're solving triangles for me, remember, go ahead and write all of the unknowns in one section for me. Oh golly, I almost dropped my iPad. So I'm going to say, all right, I figured out that side A was 20.87. I figured out that the measure of angle B is 40.30 degrees. And I figured out the measure of angle C is 99.70 degrees. Please don't forget the degree measures on your angles, right? Put a little box around that, and I'm ready to roll. Woo! Rock and roll. Okay, y'all, if you have questions, pause this, send me an email, or come to one of my Zoom sessions, all of which are delightfully fun. Okay, let's do another example. I'm gonna make this a little bit shorter. All right. Example. So what I want you to do here is find the measure of angle A. Find the measure of angle A. Okay, I'm gonna draw this triangle for us. I'm gonna try to draw this triangle for us. Boop, boop, boop. You can do it. Yeah, God, I love the iPad. So this is going to be A up here, C down here, B down here. This is gonna be 23, 27, and 19. Okay, y'all, if you are writing or if you are watching this right now, this is where I'm going to give you a secret word. And if you see the secret word, you don't get anything because I can't send you anything. But you get like extra points, not extra points, not for real extra point, but just like a mad respect from me. So the secret word is fettuccine. Secret. Shh. Maybe you'll get something. I don't know. Maybe I'll mail you something. Oh my God, what if I mailed you something? We'll see. If you watch this and you see this, send me an email that says what the secret word is. And maybe or maybe not, you'll get something. I can make no promises. That's the secret word. I just want to see who's watching this stuff and who's like actually watching. Anyway, fun times. It'll be fun. We'll see who answers that. Okay, so y'all, we just want to find this angle right here. So if I go back up to the law of sine, so I have three sides. So I know, since it's side, 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 I know that I'm going to be using the law of sines, right? But I'm going to be finding just the measure of angle A. So I think I'm going to go back and use this top one again, because I have the measure of angle A right there. I'm going to have to do some finagling to get it, but I think that's the one I'm going to use. So I'm going to go back down here and I'm going to write out that formula. So a squared equals b squared plus c squared minus 2bc times the cosine of a. And then what do you do next? Here we go. Here's a hint. Boop, 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 boop. Boop, 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 boop. Plug it in, plug it in. That looks really scary. I don't know how I feel about that. So we're just going to plug it in. Remember, that's the name of the game with the law of cosines, is just plugging in the stuff that you know. So let's do it. So I'm going to go ahead and label my sides real quick. So this is side A. This is side B. This is side C. I'm actually going to write that down up here. So A is 27. B is 19. C is 23. Not drawn to scale, by the way. Sorry about that. Okay, so let's plug in the stuff we know. 27 squared equals 19 squared plus 23 squared minus 2 times 19 times 23 times the cosine of angle A. Unknown. All right, let's do some math, y'all. This is going to be a little tricky because what we need to do is isolate that cosine of A. And then we'll do the inverse cosine to get it by itself. So here we go. 27 squared is 729. 19 squared is 361. 23 squared is 529. 2 times 19 times 23 is 874 times the cosine of A. All right, so I need to get the cosine of A by itself. So I'm trying to isolate this guy, right? So that means I need to move this, this, and this all over to the other side. So let's take these, maybe not one at a time. I'm going to do one more thing. I'm going to say 729. I'm going to add those two together. 361 plus 529, 890 minus 874 times the cosine of A. Okay, now stop. Hammer time. I am going to make just a quick comment because in a few tests ago, it became very apparent that some of you have, many of you actually, struggle a little bit with your algebra skills. So I know that there are those among you who are going to see this and say to yourself, oh, self, let me just do 890 minus 874. That's 16. That makes this a whole lot easier. Please don't do that. I can't subtract those because this 874 is attached to that cosine of A with multiplication. So anytime something is attached with multiplication, the only way I can move that out of there is to divide it out of there, right? But you don't want to divide now. You want to make sure and move this first, and then we can divide to get that out of there. So I wanted to make that clear, because I know that some of y'all are going to see that and pounce and be like, let's just keep minusing and yay, let's go. Think about your algebra, reflect, go slowly. It's not a race. Okay, so what I'm going to do first is I'm going to subtract 890 from both sides. So 729 minus 890 is negative 161 equals negative 874 times the cosine of A. Then now I'm going to divide both sides by negative 874. Those go away. And then I'm going to say, actually, watch this. What I'm going to do, I'm just going to keep this as 161 over 874. Notice that it's negative divided by a negative. So negative divided by negative turns into a positive. So I'm just going to drop those. And that equals the cosine of A. So to get the A by itself, what I'm going to do is I'm going to say, all right, the inverse cosine of 161 over 874. And the reason why I want to leave it as 161 over 874 is so I don't have to divide and then round and then type in a rounded number. So please don't round in the middle of problems. I want to keep stressing that. Don't round in the middle of the problem. Okay, so the inverse cosine of 161 divided by 874 equals 79.38 degrees. That is the measure of angle A. Hooray. Now, one thing I wanted to point out from all of this, this triangle up here, it asks to find the measure of angle A specifically without solving for the rest of it. I want to give you a very, very, very important point. Whenever you are working with a side triangle, so if you were starting with all sides, you have no angles and you're having to go backwards to find missing angles. What I want to stress to you is start with the largest angle. So if this was the beginning of a whole problem where you needed to find all of the rest of the angles and I didn't tell you which angle to find first, start with the largest angle. How do you know which angle is the largest angle, you ask? Hey, it's going to be the one opposite the largest side. So in this case, side A was the largest, which means angle A is going to be the largest. So I wanted to start with the measure of angle A. The reason that we do that is because we can stumble into an ambiguous situation if we don't start with the largest angle, and it can kind of mess up our calculations a little bit further down the line. So to prevent any of that, just always start by finding the largest angle. And I talked about that a little bit back with the law of sines. So this is where it matters. If you are starting, I'm going to go through it again. For side triangles, if you're starting with all three sides, start your calculations to find the largest angle first and then go from there. Now y'all, since I found side A, if I wanted to solve the whole triangle, I could go back and just use law of sines for the rest of this to figure out the other two angles. Use law of sines to find one of the other angles and then subtract from 180 to find the last angle. And after you find that largest side, it doesn't matter which angle you go to next, but you do want to start with the largest angle first. Okay, golly, y'all, I think that's gonna be the end of my examples, because it really is just about plugging it in, plugging it in, and just making sure you keep your algebra straight, making sure you pay attention to what you're plugging into your calculator, make sure your calculator is in degrees, if I give it to you in degrees, which I will, and make sure you're starting with the largest angle for side triangles. Other than that, I don't think there's anything else I can tell you. So I'm going to leave you with those two examples. You're going to have a go formative to do. And then, like I said, I think I'm going to put up a quick little worksheet for you to practice law of cosines on if you so desire. And I'll put up the key to that as well so that you can look at your key. And then next class on Wednesday, Thursday, we will be doing a review for law of sines, law of cosines. It is already review time. And then test is going to be next week, and it'll be the same process as the last test, which, by the way, I should have grades in, like, that's what I'm doing right now. So hopefully within the next hour or so, you should have, well, from the next hour from right now, it's 6:18 right now. So within the next hour from now, hopefully, maybe 2 hours, we'll see. Watch, it's not going to be posted until, you don't care. Okay, y'all, like I said, if you have questions, come talk to me in one of the Zoom meetings or send me a quick email. That's all I got. I hope you're doing well. Send me a photo or something. Let me know you're still alive. I hope you're well, and I will talk to y'all soonsies. Okay.